Hello, and welcome to Deploy and Serve Model from Azure Databricks on Azure Machine Learning. I'm Rima Kuvadia, software engineer in AI platforms team in Microsoft.
Hi, I'm Tony. I'm from Microsoft, working as a senior applied scientist.
We have divided our talk into three sections: model training and experimenting, model deployment, and model consumption in Azure website deployment. The first two modules will be covered by Tao, and the last one will be covered by me. Before we move on to our main agenda, I just want to give a quick overview of all the Azure resources that we are using and why. Azure Databricks. In Azure Databricks, we are using Jupyter Notebook to run the PySpark code and attaching a cluster to do the required processing to train the model. Azure Blob Storage. Once the model is trained, we are storing the model in Azure Blob Storage. You can even use Azure Data Lake. Third, Azure Machine Learning. In Azure Machine Learning, we are prepping the model for deployment. Fourth, Azure Kubernetes Service. In Azure Kubernetes, we are creating an endpoint for model that we will be consuming in Azure Web Service. Fourth, Azure Web Service. Here we will be deploying a web application in which we will be consuming our Kubernetes endpoint. All the above resources can be deployed by just one click using ARM template. Let me give you a quick demo about it.
This demo is to show you how to deploy Azure resources using ARM template. I have written a simple PowerShell script to deploy all the Azure resources we need for this demo, like Databricks Workspace, Storage Account, Machine Learning Workspace, etc. I have added my ARM templates in the template folder, and I've got these templates from this GitHub repository called Azure Quick Start Template. To further to customize my script further, I've added parameters.json where I can add the name I want, the location in which I want the Azure resources to be deployed, and manage access policy, that is security on each of these resources. To deploy the Azure resource, all you have to do is call the template in your PowerShell script. For example, in my to deploy the Databricks workspace, I've called the Databricks template and I've passed the required parameter. So if you see here, it just needs the location and resource group and stuff like that, which I've passed in the Databricks parameter. And all you now have to do is just run the script. To run this script, navigate to the file location in PowerShell and just run the script. This will start deploying the Azure resource in the resource group it is going to create in the required subscription and location. For this demo, I already ran the script before, so I have my resources already deployed in my resource group. To see if your script ran successfully and all your Azure resources were created, you can check them here, but if something failed, you can go to the Deployments tab and click here. It will show you the resource which failed and the error. Here it shows that this keyword name was already in use. So what I did is I changed the keyword name and reran the script, and this deployed the keyword for this resource group. That's how simple this is. So yeah, that's it from me. Now let me hand it over to Tao to talk more about model training and experimental.
Okay, now let me introduce the problem we want to solve in this project. So we want to solve a machine learning problem to identify the semantic type about one tabular data, which is column data. This problem is very critical in the business world to solve the data cleaning, normalization, data matching, and also data enrich problem. So right now, most of the current solutions rely on the dictionary or vocabulary lookup. So all these solutions are not robust to the dirty and complex data. So what's more, this cannot be generalized to a diverse data type. So in our project, we want to make a machine learning solution to make sure the model can have a way to learn from the data and make a right prediction. So here is several examples. So the first example is a name. So we want the machine learning model to capture all the information, especially the semantic meaning from the data, and to make a prediction, see this is the name. Similarly, for the second and third column, we want to make the right prediction to see this location for the location about the values, and also date for the last columns. Okay, now let's talk about the model end-to-end flow. So in the model flow, as I mentioned before, so we treated this problem as a machine learning problem. Then so we started with all the data gathering, and then we need to do the model training, which happened on the Databricks. So in this stage, we do the feature engineering and also model training using all the PySpark machine learning. Then we will move to the next stage. Once we have the model, we will publish the model into the Azure blob storage, which can be consumed in a later stage. Once this is done, we will move to the next stage, which is the model deployment definition. We will define the model environment and also the dependencies. So once this is done, another important is the scoring script, which is used as the entry function for the model to make the prediction. Once all this kind of done, we will go to the final stage of the model deployment, which is first register the model into Azure Machine Learning, and then create a model image. And thirdly, we just deploy the Azure model into the Kubernetes service as one web service. Once all this done, so we can use this as a serving and also consumer stage. The model will be served as a web services on Azure. And secondly, the application can fully use and consume the model using the REST API endpoint. Then this will become to be the application stage. Okay, now let me talk about some details for the model architecture and the training. In this stage, we used this one as a multi-class classification using the random forest. Here is our architecture. So we started with the data gathering using Excel data, public web tables, and some research tables from some papers. We also leverage some customer related data. So all the data will become to be processed as some kind of tabular data with the header and also value examples. We will do the feature engineering to generate the features for both the header and also values. Also, we also generate the labels based on the header to come out some kind of label about the categories. Okay, once all this done, we will have one feature vectors per column and one label, which is semantic tab. So we did the model training on Azure and published the model, which can be consumed in the production on Azure Machine Learning. So in this presentation, I will only talk about some details. In the featurization stage, we leveraged the Spark feature about the in-memory data frame to make the embedding can be easily look up. And thirdly, we leverage the Spark SQL to make sure the featurization code can be running as a UDF function to make fast computing. Okay, now let's talk about another component, which is the model training. So in the modeling, we leverage the Spark ML Lab to do the model experimenting. In our example, we use the random forest as our model. What's more, we also leverage ML flow for the model logging and also selection. Now, let's move to the second demo, which is training the model using Azure Databricks. In this session, I will demo the model training on Azure Databricks. Azure Databricks provide us the easier-to-use interface to manage resources on Azure. It also creates the cluster management, which enable us to easily create, configure, and also manage a cluster. For example, I can specify Databricks versioning when I create a cluster. It can also allow us to easily create any new packages or libraries that are needed for the experimenting. What's more, it provides us easier-to-use notebook for the modeling, training, and also experimenting. So in this book note, so we need to specify all the libraries that we needed for the featurization and also model training. And secondly, we need to link to our Azure blob storage by using the storage account and a key. And together with all the configuration parameters we need in this kind of experiment. Now we can load all the pre-trained work embedding into a memory, which can be super efficient to use in the featurization part. And after that, we need to define all the UDF functions for the featurization. This is all the function related for the featurization to this tabular data understanding. We then just use the UDF function and also lambda expression to just concatenate the functions together with the return tab into each UDF. All these UDF functions will be registered into a system to make sure the featurization can be in parallel computing and for even more efficiency. Then here is the featurization code. Most basically, we just call the UDF function by using the with column function and call each UDF to compute the features. Once the featurization is done, we will go to the model training part, which is train a random forest model by using the pipeline.fit function. Once the model is being trained, we save the model into the local storage by using the model.write.override.save function. Okay, once the model being trained and saved, we will continue the model evaluation and amendment by generating the precision record numbers per tab and the weighted precision record numbers overall. After all this is done, we can easily publish the model into other blob storage for the downstream pipeline to consume and deploy. What's more, Databricks also provide us the function that we can use, like the mleaf, which allows us to package the model into the jar package. And the model training and selection part, the ML flow can also be used to do some kind of feature parameter sweeping and also logging. Yeah, so thank you. Hello, in this session, I will continue the model deployment. Now, let's look at what's the model deployment. So in this model deployment part, as we mentioned, the model will become to be trained on the Azure Databricks, and we then published to the Azure blob storage. So yeah, to highlight that, model training on Azure Databricks, and the model will become to be published and saved onto Azure blob storage. Once this is done, the model will become to be deployed and serving onto Azure, which is running on Azure Kubernetes services. So here are some pre-requirements, which is first, Azure Machine Learning workspace and one Azure Kubernetes service cluster. Plus, we need to leverage the SDK on Azure Machine Learning and also Azure storages. The first step before the model deployment is model registration, which is register a model into the workspace, make sure the model can be stored, tracked, and also versioning. Okay, once the model is being registered, we can go to the defining stage to define the scoring script, which you already call score.py. This is to load the model and also when the deploy service is being deployed into the Azure Kubernetes services. Secondly, this function is also need to handle the data, which is from the endpoint, and also make this into the model by doing the featurization and the prediction, then returning the results as a response to the endpoint. Plus, we also need to define the AML environment, which include the software dependencies and also the libraries dependencies. Once this being defined, we can go to the second stage about the model deployment. In this stage, there are two important parts. One is create the image, basically just configure the entry script and environment, then configure the runtime, which here is Spark Pi to make sure the cluster or the image can run within the runtime of Spark. Plus, it also provided the flexibility to make even more flexible configuration, like a CPU, memory, or other configurations. Once this image being defined and created, we can deploy the image as a web service into the Azure Kubernetes cluster and then get an endpoint. Now, once the model being deployed and the endpoint get ready, we can easily consume the model by using both the SDK and also using the endpoint as the REST API services. So the one important file is called scoring file or the score pi. This one is entry function, which is used to receive the data and also doing the featurization, prediction, and also retain the result through the endpoint back to the client. So this function contains two important functions. The first one, we call this initialize function. This function is loading the model as a global parameters. We can also use this function to define some other parameters. And thirdly, this function can only be run once, which is when you deploy the model to the Docker or image or cluster. Here is one example. If you look at here, this function defined here one Spark parameter, one our machine learning model, plus one word to embedding in memory lookup data frame. So this one will enable all the models, global parameter, and also some in-memory resource can be loaded and fully used. Once this is done, Another important function, it will become to be called every time when you receive some data. This is called a run function. This function basically receives data and also make a prediction and return this. All the interface about input and output need to follow a JSON format for serialization and also deserialization. Here is one example. This function will just receive the data from JSON format, get the data, make some data featurization, and also make prediction. Once all the featurization done, we will just pick the results and send this back to the endpoint. Okay, now let's talk about more details about how to consume the model.
Okay, in this session, I will demo how to do the model deployment using the Azure Machine Learning. So it provides us a easier-to-use portal and to access the notebook and also compute plus with all the models and endpoint. Here in the compute, you can access the compute instance which is used to execute the script. And also you can also use this to manage your cluster. In this case, we have one Kubernetes cluster used to deploy our machine learning models. You can easily use this model to manage and also monitor all your pipelines. What's important, you have the notebook which allow you to do the model deployment. In this pipeline, we create one folder and the only needed stuff here is only one notebook which has all the logic to do the model preparation and also model deployment. So the first step, let's enable all the pre-requirements by importing all the libraries from the Azure Machine Learning SDK. And let's also initialize a workspace to persist all the configuration and also models. Now let's go to the first step, which is prepare the deployment. Here, we just need to connect to the Azure Blob storage and also download the models and also embedding models. Let's look at the model download, which just use a datastore.download function. Similarly, we download the embedding function as well. And then in the second step, we will register all these two models into the Azure Machine Learning space. So let me take a look at whether it's a model. Here, if you look at the models here, you can access all the models that was being registered into the Azure Machine Learning. Okay, once this model was being registered, you can go to the third step, which is deploy the model and web services. Okay, now let's just specify the compute target. Here we choose the Azure Kubernetes clusters that we want to use. Here give us functions. And then lastly, let's specify some Azure Kubernetes configuration to config. Like here, we just have 2 CPU core and also 4 GB memories. So it also provides you even flexible usage to just configure the computer and also the auto cluster. Once we finish configuration, we will go to the image creation part by using container image and to create an image with the execution script score.py and also runtime, which is spark.py, and also a conda file, which is environment.yaml file. Now, let's first look at what's the YAML file before we do the model deployment. The YAML file is just a single file, contains all the dependency. Here we just specify the library about the Python and the PySpark with the versioning. And then with all the packages that needed to be installed on the cluster. Okay, and another important one in order to do the deployment is the one we call the spy.py, which is this function, which is entering function. Let me take a look at this function. This function, as I mentioned, basically has 2 most important functions. One is the initialize function, basically just define all the global parameters. In this case, we define the Spark environment and also the model plus the model to word embedding and also some other global parameters we want to use. So for Spark, we define a Spark session in order to use this for each model prediction. And also when we do the model loading, we use either SDK, get the model path, and then load the model using the Spark code pipeline model.load. Similarly, we did the same thing for the embedding, but use a different function, pickle.load, to load and read the embedding file into the memory. Once this is done, here we also have a similar function used to do the featurization. And together, we also have another important function, which is run function. This function is needed to just receive the data from the endpoint, which is JSON file data, and then doing the featurization, which is pass the data from the JSON file. And once the featurization is done, we converted the data into a Spark data frame, and then continue the model scoring and prediction. So then after prediction, we may do some kind of data post-processing and to adjust some prediction, either to reject the prediction with some low probability. And once all that done, we will return a result. So the result will become to be serialized by a JSON format. Then this result will become to be returned to the web service. We can also handle some exceptions by using the exception function here.
Thank you, Tao, for getting the model ready for us to consume. Now let us see how we can consume this model into our web application. To consume the model, we first need to register it in our machine learning workspace. Here is the code snippet to register the model. We will be needing path, name of the model, description of the model, and the workspace. Once the registration is complete, we are ready to create an endpoint. We have few dependencies which we will be declaring in the environment config file. I have added snippet on how this looks. In the next demo that you will see, I will walk you through how to register the model, create your workspace, and how to consume the YAML file. Once we deploy the web application, this is how our web application will look. So to test our end-to-end model, if you give an input, the model can detect what type of column it is. As you see in the first column, the name, it detects as first name. In the third column, it detects the company name. To complete this model end-to-end, let me walk you through a quick demo.
In Azure Machine Learning Workspace, I have created a script called model register and deploy. I'm first initializing the workspace. Then I'm registering the model. This is the same code snippet that you saw in the slide, where I'll be needing the model path, the model name, description, and the workspace that we initialized in the earlier step. Before we proceed to the next step, we will be needing two things, the scoring script and our environment config file, the YAML file, where we will be declaring all our dependency. Going back to the script, the third step is creating the endpoint. To create this endpoint, we will be needing three things. The scoring script, which will be our execution script, defining the runtime, which will be PySpark, and the environment config YAML file, which will be our conda file. When you run the script, you will see that it is creating an image. Once this image is successfully created, you navigate to the Endpoint tab in Machine Learning Workspace, and if you click on any of this endpoint, you will be able to see all the details of this endpoint. Here, you will see the REST endpoint. Just copy this and keep it ready for the next step. I have created a simple .NET web application, and in my web config file, I have copied the URL, the REST endpoint URL, and I have pasted here. Once your application is ready, all you have to do is go to your solution, just right click and click on publish. Once you click on publish, since we had already deployed app service plan, you can use that one, or you can create a new one by just clicking on Azure and app service windows. And here you can select your subscription, the resource group, which if it already has app service, you can select that, or you can create a new app service plan. Since we already have it, I'll just continue with that. And you can select one of the app service. And then all you have to do is publish. Once you publish, it will give you a site URL. And when you click on that, it will open a website which will look exactly like this. To check if your endpoint is properly configured, I'm going to show you how I can verify that. I go to launch and I give a manual input and I put name and I put my name and Tao's name. It will show me, it should show me as a person full name if you see. Just another example. I'm going to change the input from names to company. And let's see what output we get. So this is company name. This shows that my end-to-end from model creation to model consumption is working accurately. So this is my demo. Thank you.
To conclude our talk, I would like to say we have achieved end-to-end model training to model consumption using Spark APIs and Microsoft resources along with third-party platforms like Databricks. I have attached all the links for your references. Hope you guys have enjoyed our talk. Thank you from Tao and me.